Hi, I'm the director of the Connected Intelligence Center, which, for those of you who don't know, is a research-informed innovation center for UTS. We report to the DVC for education and students, but we conduct research into the use of data analytics and AI for teaching and learning. But that expands into research as well, because obviously many students are doing research too. And we ourselves are researchers as well. My background is in human-computer interaction and learning technology, and I come from the human sciences. Lisa, do you want to say a brief word?
Okay, I'll try my best. Apologies, everyone. I just have to point out that I suddenly got hit by an allergy, so I might be sneezing every now and then. I'm Lisa. I work very closely with Simon in the Connected Intelligence Center. Mainly, my background is in education, and I have a focus on feedback, specifically feedback that is based on learning analytics. But basically, my role is also to support academics to implement automated feedback into their subjects, as well as to research what is the impact of that implementation. So I'm a researcher myself, and qualitative research is part of my job as well. So thank you for the opportunity to share today.
Thanks. Antonette Shibani, PD School. She can't join today, I'm afraid. Ram will roll up shortly when he's finished teaching. So should be here for at least the second half. Okay, Lisa, do you want to jump to the next slide? Because this is the sort of the overview. Um, so look, the provocation here is, to what extent do we think the future of qualitative data analysis is going to be hybrid? Humans and AIs working together. That's our provocation for today. And that leads us to questions such as the following. You know, if you're into theory-grounded deductive coding, how do you move from what you currently do into a system prompt that will guide the large language model? The system prompt being the instructions you give the large language model or the chatbot to put it into a particular role to perform a particular kind of conversation or analysis. Next question we might ask, um, how do we evaluate the quality of the coding compared to human researchers? That's an obvious question that we want to ask. But when we get into inductive coding, that becomes an interestingly complex question. Uh, Next one. Since, like humans, language models are intrinsically variable in their coding, how do we understand and manage that variability? You may not get the same thing out of a language model the second time round, a bit like a human. So, but it turns out there are some interesting things we can do to manage that. Next, we might be asking, how can a language model provide a transparent account of what it's done? Okay, we can't just have a black box that says, here are my categories. We want to know how it's done that and why. The next one is, I suppose, a restatement of the top one, really. It's about how are they going to work together in the future? How are humans and machines how do we bring their relative strengths to potentially do a better job than humans on their own? And of course, that's a controversial statement, because what do we mean by a better job in the world of qualitative data analysis? It can't just be about efficiency. Might it be quality, not just quantity and speed? And of course, finally, what concerns do you have about all of this? This excites pretty strong reactions from people. We're not here to say the future is AI, um, everybody go home. This is about us opening up a dialogue to really help you understand what we're doing, help us understand what kinds of concerns you bring, because this is absolutely central to the future of qualitative data analysis. And people are having similar conversations in the world of quant, but it's a little bit easier in the world of quant than in qual. Okay. And what we're presenting today is actually sort of the distillation of two separate conference papers that we presented about a month ago in Dublin. The references are at the last step of this slide, Lisa. And so you can chase these down later for the details. Okay. These were both presented at the International Conference on Learning Analytics and Knowledge, which is dominated now by the use of language models for studying educational data. And we will be presenting examples from educational data, but we're going to make the claim that this could generalize to many other kinds of domains. All right. That's what we're doing today. Over to Lisa then, who's going to present the first paper on inductive coding.
Thanks, Simon. So what I'll be sharing with you in this part of the session is just to talk about how we went from transcripts to themes using a large language model approach. So to start off, just to give a little bit of background to this. There were humans behind this AI team, and this was the project team led by Dr. Anisha Bakaria from UQ, and the three of us over at UTS, and finally Trish McCluskey over at Deakin University. So we were a multi-institutional team. Just to give a little bit of context, we're working with data, so you probably want to know where this data is coming from. The context is really a large multi-institutional study, which you can read more about in this website. But really, the overall aim of this large project across multiple institutions is to understand student users of technology as well as their perspectives on Gen AI. So it was a pretty big project, and we took a mixed method approach using focus groups, surveys from gathering students from across the 4 universities here. But for the purpose of this study, what I'm sharing about, it's really to examine the potential of LLM-based workflows to support the qualitative research process for researchers. So in this sense, we are only focusing on the data from the 20 focus groups with these students. So we like to introduce this tool that was developed out of this project, which is called the Theme Explorer. And we like to describe it as a trustworthy LLM-based tool for qualitative analysis. So, well, why trustworthy, and what do we mean by trustworthy? So in the first place, we actually need to identify what are the requirements for building a trustworthy tool. What is the requirements for the trustworthiness of an LLM-based qualitative analysis tool? So 2 requirements. The first one is to make sure that the integrity of the coded textual extracts is maintained, because we know that LLMs do have a tendency to hallucinate. So in order to achieve this, we had to build in steps to verify that quotes were not hallucinated and that they were also meaningfully classified. The second requirement was also to maintain the transparency of the coding. So we know a lot about these. There's a common criticism that a lot of these are black box systems. So in order to make sure that we know whether how the LLM had developed had created those codes, we built in steps to explain the rationale for its coding and to be able to trace every code back to the source data, which is really important so that humans can be in the loop to verify the coding. So in essence, the Theme Explorer was really designed to enhance every step of the qualitative data process, the extraction of themes, validation, and visualization of the themes from the data, while allowing the human to be in the center, the researcher to be able to monitor and to also query and make further sense of the results from that data from the analysis. So just very briefly to get you behind under the hood of how this LLM workflow actually worked. So for those of you who are more technical oriented and are curious about what went into the system, so what actually how this works is that the whole process takes a few steps as well as a few prompts. So first we start with the focus groups transcripts, which are fed into the system, and then through the first prompt we got the LLM to extract the themes from every transcript and then validate these quotes to make sure that they are actually coming from the data. And then combine all the themes across the various focus groups. in order to find similar and overlapping sub-themes using clustering. And this leads to the second prompt, which is to validate if the sub-themes are semantically similar, and leading to that final prompt where we want to create those higher level meta-categories. So what you get is this nice user interface, which I'll go through in a short while, to allow human analysts and researchers to explore and edit the themes that come out of the analysis, and also to dig further into the transcripts for more insights. So this really is the user interface of the system. It's designed to be really interactive, and really the signature of this tool is the Sankey flow, in order to show that tracing back, remember we talked about those two requirements for trustworthiness. So being able to make sure that we know where the themes are coming from, being able to trace back to the original data. So on the right side, we have the data source, and then each focus group, followed by the themes that were identified, and then how these were defined into the higher level categories. Here's just an example of the categories that emerge from the analysis of that data. So the system actually, LLM actually identified 8 or 9 themes, and you can see from the length of the bars, the kind of like the prevalence in the data. So as you said, the tool is really designed to make sure that that the researcher is able to explore the data, explore the analysis outputs in more detail. So it's built with a lot of interactivity in mind. For example, you can go into, it allows a dialogue with the themes that were actually explored. So you can actually click on the particular theme that was identified, and then and just look at what was the rationale. And so this addresses that idea of being able to explain why the LLM created this category, what were the key words, as well as what were some of the what were the merged themes that fall under this category. And you would even be able to dig into each quote that was identified to make sure that it actually exists in the transcript, and also to see it in context. Not only that, so it is an inductive tool in the sense that it works from the ground up, but researchers also like to do have some themes that they want to explore, and so there is an ability, a feature for researchers to do that, to create their own custom theme, and to explore, to see whether these themes are sort of viable themes that come out from the data. So what it does is you would just search for a term or a concept that in order to see if that theme actually exists, and the tool will actually retrieve some excerpts from the transcripts, and you would then be able to select those the ones that are more relevant, that would be suitable for your new theme, and then give it a final theme name. Okay, so that's all well and good, but as we said, that's just one part of the process. We also need to be able to evaluate well, we're talking about how trustworthy are these findings. How do we know that the tool is actually doing a good job in making those analytical decisions? So there are two ways that we evaluated the output. First is to compare two different approaches, which is the 3.5 as well as GPT-4, and we found that there was actually a difference based on fuzzy searches, in the sense that the GPT-4 was actually more able to identify fewer invalid quotes, meaning that even when they didn't have to have exact matches in the quotes in order to identify that as a quote. So that is important. And the second evaluation method was to sort of compare the theme's interpretability compared to the traditional approaches, for example, through LD8. So when we compare this the LLM approach versus a typical NMF or LDA approach, you can see that basically the difference is that in the traditional approach, you have all the tool is able to group all these individual items together, but it's up to the researcher to kind of put that label or make that sense of all these terms and what do they actually mean. So whereas the LLM is able to put a label, a pretty meaningful label onto these terms so that this helps with the researcher's sense making of the analysis. So what did we learn, and what are some of the limitations and future work of this project? We found that basically it was really important to have these inbuilt validations. So it took a number of iterations to get the process right, but these were the key things. So making sure there were inbuilt validations and aim for verification, not so much validity and reliability, which is actually what is definitive of qualitative research. We also recognize a limitation which has come up in some of the critical reviews as well, that LLMs are really good at summarizing ideas, summarizing findings from documents, but they may not be able to actually capture the latent meaning in what people in transcripts such as these. So what is beneath the at a more lower level, what does it actually mean, or what are people actually saying about those particular themes? So it doesn't get into that particular level of detail. And so based on all this, we do feel that it is best to work with AI together to have that partnership for AI to augment human intelligence rather than to totally replace it. So what's next is, this is just kind of like a prototype of the tool. So we're aiming to make this tool more usable for qualitative researchers. Right now, it is tuned very much to the data set that we have, which I've just shown you, and to make sure that we mitigate the propagation of bias. To ensure we're able to validate the coverage of themes through AI and human comparative analysis. And so with all that done, we aim to move towards a open source release sometime over the next few months. Simon, should I go through a quick demo or? Sorry, didn't hear it.
We could, but I'm wondering whether it would be more useful just to throw it open for some questions and conversation. We can make available a video demo, and as I've been putting in the chat, we are moving to getting a version running here in UTS, which will also be research grade secured, so you can put research data in there with confidence. Perhaps we should just throw it open for some questions before we move on to deductive coding.
So I see a question from Emara, which is how do we ensure consistent coding results across multiple runs with the same data? I guess this is something that we are looking to improve as well. Right now, when we did run through this with a few iterations, it was able to provide pretty consistent results. So pretty happy with that, but definitely we need to explore this a little bit more with other data sets as well. So that's the question I can see here. I hope that answers Amara's question.
Another one there from, it's a pretty interesting question as to what does it mean by consistent coding when you're doing inductive coding? So this is where we get to the heart of to what extent are you more positivist or more interpretivist? It's a nonsensical criterion to demand the same output from different people if you are very strongly interpretivist, right? Because they're bringing their particular perspective. If you're happy with the idea that multiple people are going to do the inductive coding and come out and then look at the alignment between the codes, then yes, we can ask these language models to repeat their coding. And you certainly you get different language, you get different high-level categories coming out, slightly different, depending on whether you use one language model or another. So we already see it's a bit like humans in that sense. But the high-level codes, of course, are quite abstracted buckets. They're very broad buckets, the kind of thing that you might do when you're beginning an analysis. And they don't change drastically. But another important question that we need to investigate is whether important but not very prevalent phenomena make sure they're not being ignored either. So that's an interesting question for exploration. To what extent does something that you consider to be extremely interesting not get picked up by the model because it only happened once or twice, right? So these are the interesting human AI interaction questions to be exploring. We've got some more questions. Okay, Vicky asks, did you ask Claude about your design as well as using him as your generative AI? Now, are we talking about the design of the study? I think the whole research design. The answer there is no. We are simply using the language model as sort of research language technology to analyze our data. We're not chatting with Claude in chatbot mode. We're not using it as an ideation tool to plan research, although that's a perfectly interesting and legitimate thing to think about doing. Okay, Victoria's asking, what is JSON? What is Jupyter? JSON is a data format. Jupyter notebooks are widely used amongst data scientists and statisticians to structure their analyses in reproducible form. What else we got? Helena. To calibrate the human LLM coding, is it possible to go through iterator reliability? Yes, it is. That's exactly what we are going to show you when we talk about deductive coding. We have not done that with inductive yet. And we're having some very spirited discussions with our qualitative research colleagues, aren't we, Lisa, as to whether it even makes sense to them to compare what we came out with what they came out with. So we actually ran a little experiment. We called ourselves Team Machine. They were Team Human. And we did not talk to each other at all about how we were doing the analyses. And that is now part of our research, which is to compare and contrast how they worked with how with what the language model did. And that will actually be the subject of some of our future research papers, hopefully. And they are already publishing research that's coming out from their Team Human work. And we are just trying to find the time to actually sit down and have some really deep conversations with them about how they would use a tool like this, whether they think it adds value.
I'll take a stab at answering Carla's question, which is so far the last question I can see. Without the Theme Explorer tool, as this may be quite a ways off for most of us to use, do you have tips and tricks for how to use Claude or GPT for thematic analysis? And how does Copilot compare as it is the accepted UTS platform? So I'll just share, I guess, from the experience working with this project. I think the key thing is really to make sure the key limitation really of these LLMs is that they do tend to hallucinate and be pretty convincing about it. So we need to make sure that we design a prompt that is very clear that the whatever output is produced is really able to be traced back to the data. So I guess the key would be in the prompting for using the general tools, like for example for Copilot. I'm also not sure whether with a tool like Copilot, whether then you would need to feed in the transcripts one by one, and then how you would get whether it would be possible to get a overall sense of the themes or the analysis across a whole data set. So that's something that might need to be explored.
Yeah, I mean, I think a key point to make is here, we've got quite a complex workflow. Remember that workflow slide Lisa showed, right? Those are the sorts of methodological, rigorous hygiene steps that we are trying to put into the workflow here, which goes way beyond typing a brief prompt into Copilot and pasting your text. Okay, we're trying to really get this into something really rigorous. So it's got these checks in there to make sure it's not making up quotes, make sure that the themes are semantically coherent, and so forth. That's what's detailed in the papers. So we're trying to move this beyond, just using Copilot or Claude or some chatbot to something that's really methodologically rigorous and reproducible, with code that can be checked by other researchers as well. So yes, Copilot is the current UTS approved chatbot to use if you want to be having online dynamic searching. Recast has just been launched, which some of you may not have come across yet, but I'll drop the link to Recast in, which is the UTS secure chatbot portal, which is being gradually rolled out now for staff and students. And now what we're talking about is using the UTS secured large language models like GPT-4o and others as part of your research workflow. And we're not chatting to a bot here. This is a workflow with automated steps calling GPT-4 and Claude APIs, right? So you submit all of your data in one go. It's all being programmatically automated. We had over 20 hours of transcript here, and I think that was analyzed in about 10 minutes or something. Okay, so this is where some of the interesting questions come up about cost-benefit trade-off here. If in 10 minutes you can get a first-pass analysis that places your quotes into broad bucket themes, is that of interest to you? Is that a game changer for you potentially? Especially if you then go into subsequent more detailed analysis using the user interface that Lisa briefly showed, where you might start checking and drilling into the themes and so forth.
So Robert's got a question. So is the validation done by humans? Would say that it's done by both. So we get the LLM to validate by showing, we show the rationale for why it has merged those keywords or those topics together, and then because of the interactive nature of the tool, we can also do that. It's transparent basically to allow researchers and humans to go through that validation as well. So, I mean, typical with any qualitative research, when you have like two coders, you would then be able to check in with each other to make to ensure that there's some agreement or that codes make sense. So I would say it's done by both the human as well as the machine.
Yeah, there are certain checks that a machine can do very well. Is this quote actually in the transcript? That's a perfect task for a machine to check, right? We're just literally doing a match as to whether a quote that it says is under a particular theme actually exists in the transcript. But then, we need to do human checking as well. And we are seeing some errors for sure. We're seeing quotes that don't seem to fit. And that is part of our human checking. And that will, of course, vary widely depending on what data you're working with and who you are and what you think fits. Yeah. Okay, look, we can come back to this, but that's your lightning tour of inductive coding. I'm just going to bring up my slides. I can see one more question there from Vicky. Do you want to pick that one up, Lisa?
So the question from Vicky is there anything commercial like Theme Explorer already in existence and able to be used while we wait for yours? To the best of our knowledge, we are not aware of a commercial tool like this. So just to share, when this work was presented at the conference we talked about earlier in Dublin, and a whole workshop full day workshop was actually devoted to people who are researching this space as well. So people are trying to come up with tools, but the important process of checking it and making sure that it's actually working is still is very much in the works. And I think what we're seeing also is, while it may work pretty okay for us, we still need to make sure that it's applicable to other cases. I'll just share that one of the key criticisms that came out of that workshop was that these tools seem to only address the current research project of that particular researcher developing the tool. So can we make these things scalable, able to cross various projects, various disciplines, various questions? Yeah. So that's where we're at the moment. I think it's a process that might take some time, but people are interested and working on it for sure.
Yeah. And we really are hoping to be able to get this to you within the next few months as an internal research web application. And maybe we should chat to you, Wade, or others in the office as to how we might accelerate that. Okay. All right. So this is the second part where we're talking about deductive coding. You're all seeing that, yeah? Okay. So this was another paper. This is also with input from Naz Matahi at UniSA. So here we're talking about, we called it when the prompt becomes the codebook. Because what we're talking about is, how do you move from a coding tree, which you have developed in whatever methodology you used for developing your deductive coding tree, grounded in theory. How do you then move that into a system prompt because you want the language model to automate that deductive coding? Okay. All right. Okay, this picture is in the paper, and this shows the entire grounded prompt engineering workflow, and we'll use this as the map for the presentation as well as we step through it. So you don't have to digest all of this in one go, you'll be relieved to know. Okay, so let's start with the codebook. So we are developing a deductive coding scheme for students' sense of belonging at university. That's our domain. ABC of engagement, affective, behavioral, and cognitive engagement in your learning. That's a theoretical framework from our domain. Okay, and we want to develop a codebook that captures what we consider to be the core taxonomy of codes that we're going to use. Okay, so there it is. Affective engagement breaks down into sense of belonging and expressing emotions, and sense of belonging can be talked about in the literature under at least these four categories. Okay, and that in fact turns into quite a rich coding tree, which you can see. So the first step is you develop your coding tree, and we show the mapping against the key sources in the literature which justifies each of these codes. So that will not be terribly unfamiliar to any of you who've done deductive coding, right? You can't just dream up this taxonomy. Ideally, it's rigorously grounded in theory, a conceptual framework, the research evidence, or whatever. So that's our version of justifying our coding tree. And sorry, if we sort of just zoom into that, you can see that under academic belonging, there's a further set of subtypes under that. Okay, so we're going from codes to indicators grounded in the literature. The next step is to do what many of you will have done, which is manual coding of a sample of the data, resolve differences, and shoot for an acceptable inter-rater reliability using Cohen's kappa here, a score of 0.74, which is a substantial level of agreement that gives us some confidence that this coding tree we think makes sense. Okay. Right, so that's the human bit, nothing new there. Now we move into, how do we teach a language model to do this? Okay. Oh, just to give you an example, this is an example piece of text. This is what we're talking about. It's from the business school accounting program. The students have written a reflection on how they're going with accounting, why they're doing it, what they're hoping to gain from it. 860 pieces of student reflective writing. think about how long that would take you to code using that coding tree. Okay, we are talking a lot of time and effort. We put this through our workflow and it did it in under 8 hours. Okay, so that's the sort of speed we're talking about here through an automated process. That's still a serious amount of language model thinking and reasoning going on here. So it's not instantaneous, but it's a lot quicker than humans. And we can do it again and again and again, as you'll see, to achieve some sense of the reliability of the coding. Okay, so now we need to go through an iterative prompt engineering phase to confirm the quality of the outputs. We're using something called chain of thought reasoning so that the language model can explain itself. You'll see that that's pretty important later. Using the language model to analyze the same 20 reflections that were analyzed by the team and confirm that validity of the analysis. Okay. Oh, we're missing something here. There used to be an annotation here which showed that we achieved an acceptable level of inter-annotator reliability. So we're using that term to refer to the comparison of the GrowPro the language model's coding compared to the human coding. Okay, human coding was inter-rater reliability. Here we're using inter-annotator reliability, IAR, to talk about machines versus humans. Okay. Now, the interesting thing about a language model is that you can ask it to explain its coding. So this is a major breakthrough in the use of automated techniques. We could never ask a clustering algorithm or a topic modeling algorithm to explain its working. It just said, here are your clusters, and you had to figure out whether they made sense, and you didn't really quite know why it meant something. So here's a quote from a student's piece of writing. Okay, and the language model says that's an example of feeling anxious, and it can explain why. Okay, this is pretty interesting because now we can actually get some sense of what's going on in the quotes mind of the machine. Of course, it has no real mind. We don't need to get into the philosophy of that, but it can provide an account of why it thinks this is an example of feeling anxious. Just to give you a sense of the prompt, this is, obviously you're not expected to read that, but this is the structure of the system prompt that we ended up with. And in the paper, we describe how we went from a very simple, quite naive prompt at the beginning to this quite complex and well-structured prompt. First of all, you tell it what its role and goal is. Okay, you are going to act as a researcher in my project. This is what we're doing. We're analyzing students' experiences. Then we describe each code in that tree with examples. So here's one of the major leaves of the tree, academic belonging. There's the definition, and here are two examples of what we would code as academic belonging in our coding practice. Then we have the step-by-step instructions that basically tell it how to go through, how to generate the report, and how to make its reasoning explicit in a table. And there are some constraints here as well. Okay. Oh, sorry, I misread it. Okay, here's the validation then of the output. So very comparable to the human levels of agreement. The machine is coding with a 0.76 coherence kappa. Okay, so that's our check that it's not just coding nonsense. Okay. Now, this is something we borrowed this concept of large language model quotient. This is asking how can we be confident about the coding? Okay. So before we dive into this, imagine if you'd done some coding and I want to know whether that's trustworthy or not, or would you do the same again if I gave you the same text, right? Now, obviously, you can't see that text for the first time again. You've already been through it once. So the question is, but the interesting point is that we can give this text to the language model again, and it sees it for the first time if we're careful. So we can say, code this reflection again. Okay. We could say, code this reflection 10 times. And you can see here how confidently it coded this reflection number 5 using our high-level codes. And we calculate this large language model quotient, which comes from other work by Rob Tai, who's now at ACU here in Sydney, to get some sense of how reliable are these codes, right? So it turns out that belonging to surroundings is, it's not at all confident that that's in the text at all. But it is quite confident about these other 4 codes. And you can also see that if we give it to it 20 times, 30 times, that we see interpersonal belonging starting to be coded more confidently, up at 0.9 now, and then it stabilizes out. So we are building in a sort of a control for the inherent variability you get from the language model. Whereas, academic belonging, for example, was coded at up at 1 right from the start, very confident that this is there. Okay, so now we have for the first time some insight into whether we would make the claim that it is coding this in a trustworthy way. Interestingly, you go to a different text, you might get different results. Okay, so there's something different going on in this text, but it is consistently at 0.3 for interpersonal belonging. But it's still very confident about academic belonging and experiencing emotions. Okay. We've then extended the work that Tai et al. Did and defined something we called aggregate LLMQ, right? So now we're going to take all 20 texts, but examine what happens for one code called experiencing emotions across all 20 texts you can see here, 1 to 20, right? And we can see that in general, for this code, they're all bunched up at the top, and the language model is quite confident, although with some variability in the texts, right? But it's quite confident overall that experiencing emotion is occurring in those texts, except for this one here. That's a pretty interesting text to go and have a look at, we might think. So there's an example of where, at scale, the machine is perhaps pinpointing texts which might really merit human inspection to find out what's going on here. Why is that text so different? Okay, so this is the first steps to what we're calling aggregate LLM quotient. And I can see Ram's just joined us as well. This is his PhD work, so he'll be available to answer all the hardest questions, which we don't want to respond to. Okay.
Thank you, Simon.
You're welcome. Okay, so that's the overall process we've just walked you through. Okay. One thing we want to tell you about, which was quite interesting, is that down here, I didn't have time to drill into it, but this is the expressing emotions one, and it talks all about feeling different kinds of things in your text. Okay. And we had feeling interested down here. Okay. It's in there along with other feelings. Okay. But when we run the language model, sections that we had coded feeling interested, it was putting up here. It said, that's academic belonging. And we couldn't get it to change its coding. So we just kept getting this error. And so we asked it, why are you coding it that way? We asked it to redraw the code hierarchy and place feeling interested in the right place, okay? Under one of these 4 subcategories of sense of belonging. And then it said, so now we are into chatbot mode, okay? Up till now, we've just been using the language model as a natural language processing engine, and we throw the data at it. Now we're into chatbot mode using a chatbot interface, and it places it under academic belonging. Okay. Why did you put it there? That's exactly the question you might ask a colleague. Why are you coding that way? And of course, being a chatbot, it can answer. Okay, I placed it here under academic belonging because feeling interested in one's academic pursuits is closely tied, blah, 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 blah. Okay. I hope this explains why I placed it under academic belonging and not down at the bottom of that tree. Okay. We were convinced. We decided that that was actually a better way of coding feeling interested. And we changed our coding tree. So that, for us, was a bit of an aha moment. We now have another voice in the room that's able to explain its coding, defend its reasoning. It doesn't mean that we're going to do what it says, just like it doesn't mean that you're necessarily going to do what I say in the team. We're going to have a good discussion about it. Okay. Now, in the literature, there is also evidence that of what's being called large language model sycophancy. Okay, so in the training of these things, when OpenAI, Google, Anthropic are training these language models, they're training them to be helpful assistants. They're happy if you're happy. If they get the sense that, so they're not going to by default push back or challenge you. So I wanted to then ask, are you sure about that? And it goes, I realize that may not be the right answer. It backtracks. It thinks that I disagree with it, and it's backtracking from what it just told me it thought was the best way of coding. And in fact, it says, maybe feeling interested should now be a broader category up there with the other 4 main categories, and we shouldn't bunch it under any one of the subtrees. All right, now, we didn't go with that. We felt that feeling interested was indeed much better under academic belonging. But it changed its mind, and it came up with another suggestion. And it might be that in your context, you actually think, oh, maybe feeling interested is such an interesting and important category. We don't want to box it under any of the trees. But we didn't go with that in this case. Okay. So that's also a sort of a warning around the desire to please you see in some of these generic bots. And we felt it had been helpful here, but less helpful here. So take warning. Okay, so just to wrap up this section then, we're offering GrowPro as a methodology for designing the system prompt that puts your language model into deductive coding mode, grounded in whatever theory or framework that you are using. It was able to perform deductive coding with measurable consistency. Both internally, we showed you the LLM quotient model metric for internal consistency, as well as external validation, that is, how did it compare to the human coding, inter-annotator reliability. Secondly, we showed you that example in the context of some serious work we're doing. As I said, this is Ram's PhD work, in the broader context of research into to what extent can we pick up evidence of student sense of belonging using data science and analytics and AI techniques. And finally, we've shown you an incident where its ability to explain itself is actually for us an interesting example of human AI interaction. That the agent is a new voice in the room, offering its perspectives and able to engage in a conversation. We don't need to make any ontological or philosophical claims about the status of this agent as an entity. All we are saying is that the process of engaging in a critical, reflective conversation can be productive for researchers. Okay. Of course, there are limitations to this work. It was a relatively small coded human sample size of 20 to establish the validation of the coding tree. We could have done more iterations on the LLMQ internal validation, and we may well be able to do that in the future. So future directions. We already have one researcher interested in testing our GrowPro methodology in the context of his research. Obviously, we want to establish that that works beyond just our own domain. We are beginning to talk with the Thai et al. Team who developed LLMQ around the aggregate LLMQ measure we showed you, and as to whether we could develop some new metrics that would very quickly pick up broad patterns of change within the whole corpus. Do we have jagged lines? Do we have lines that are doing that and then stabilizing? Do we have a wide distribution of lines, or are they all very closely bunched? We should develop some metrics that would tell us that. The visualizations are handy, but you've got a large data set. You don't necessarily want to have to look at thousands of line charts, right? We should be able to spot that in the data. And finally, this intriguing question for us as to whether the future of QDA is hybrid human AI. And there are many quite legitimate questions and concerns about the ways that this could be misused or abused, or simply dull our ability to do analysis and not get carried away by the amazing speed and efficiency with which it does some of this work. Okay, we'll stop there and take a few questions about this deductive work, and then we've got time perhaps for a few broader questions if you're seeing connections to the inductive work that Lisa presented. Thanks.